Hello everyone, my name is RODRIGUEZ-HERNANDEZ. I am a computer engineering student from the University of Puerto Rico at Maya West, and today I'm going to showcase my database system class project called SportsTracker. So SportsTracker is a web app that have information about exercises, championships, team, athletes, sports, and this data is in a Postgre database that is hosted in Heroku, and it's hosted in Heroku with the backend that is made using Python and Flask, and the frontend of the app is runs locally, and we made it using Streamlit. So additionally to the backend and the frontend, you can also interact with a AI assistant that answers exercise questions that was made using LLaMA, and we use two models that I'm going to explain in a brief moment. So before explaining the logic that we use to make the AI bot, the AI chatbot, I'm going to explain how we made the backend. So the backend was made using the MVC pattern. This has a controller that has the roots for the API, and the controller calls the the API request a method, and this one calls the respective handler. For example, I have here the get exercise by ID. No, this is the delete instruction. So this one is going to call the exercise instruction handler, more specifically the delete exercise instruction. So if I go here in handler, as you can see, I have here exercise instructions, and here is going to call delete exercise instruction, and the handler is going to make sure that all the information in the request that needs to complete the request is given, and then it proceeds to call the data access objects, this one being the delete exercise instruction. So then it's going to go to here, going to go to exercise instruction, going to ensure that, for example, if it's going to delete the exercise, well, I have to make sure that the exercise exists, and if this one has a foreign key that points to an instruction, so it has to make sure that the instruction also exists, and then it's going to delete the instruction. So insert, so here it's going to go to this function, it's going to access the database, and it's going to delete the instruction. So this pattern repeats for every request in the database. So all of this is going to be portrayed in the front end that is in this view folder, and here is going to be the chatbot. It's going to be some graphs. We have a login and sign up functions I'm going to showcase in a brief moment. So as I mentioned earlier, we have also this chatbot. This is the chatbot class that it gets called by the frontend when it gets a input from the user or question. So we use two models. We use the LLaMA 3.2, which has a 3 billion parameters, and the IBM Granite 3.3 model. So the first thing that it does is to embed the question for everyone, for someone that doesn't know what an embedding is, it's basically transforming the question in a vector, and this vector is going to be compared to other vectors in the table of database, and it's going to see which vectors are closest and if the closest are going to be related. So the first question, you can see it's going to be embedded, and it's going to be an input for our first model, which is an instruction-tuned large language model, which is the IBM one. We basically use this model to give memory to the bot. We basically say, so look at the question, look at the chat history. If you think that this question depends on the chat history, just reformulate this question so it doesn't depend on the chat history. Why is that? Because the second LLM, which is the LLaMA one, he takes documents from the database to answer the question. And the question, we use retrieval augmented generation for this, and it needs to embed the question, as I said earlier. And if the question doesn't have information about what the user wants, then when it gets embedded and sent to the database, it's going to retrieve documents that has nothing to do with the question, and the AI won't have information to answer. So that is why it's important to reformulate the question. So as you can see here, this is the Granite 3.3 model, and then the question gets embedded here, and then we use the get fragments, then get documents, and then we use the second chat of LLaMA, the LLaMA 3.2, to answer the question, and this one is the one that outputs the questions to the front end. So now I want to showcase the project. The first thing I'm going to do is to activate my DNV. In here I have the dependencies to run the front end. So if I don't activate this, then I'm going to be in trouble. So I'm going to type Streamlit run view / frontend.py. The first thing that it's going to load is the sign in page. I want to create an account. Oh, my bad. I'm going to create an account. I'm just going to put here Dave upr.edu. Put Dave here. Password, I'm just going to put 8 zeros. If you don't put 8 zeros or just 8 characters, going to throw an error. Same with the UPR. If you don't use an UPR email, so it's going to throw an error. See, I'm going to create an account. It was created successfully, and it logged me in. So I want to show here in DataGrid I have the database. If I go to users now, you can see Dave was added, the password was encrypted, and here, now that I'm here, I can show the fragments table. This one is the embedding table that I was talking earlier. This is a vector table, and here basically is where the embedding occurs. So when I was creating this, I basically just go to this table docs. This table docs is the one that has all documents related to the exercise for the AI to answer, but you have to split these documents into smaller chunks of text. So when you make the embedding in Python, well, remember that embedding all that does is basically to compute a vector based on the question. And if you like split a document into smaller chunks, well, you have more probability to find a document that is related to the question. So basically, we just split these documents in chunks. There are around 800 documents, but there are around 2,000 fragments. So in here you can see the embedding. This is just the vector. So yeah, so the first thing I'm going to showcase is the statistics. These are just aggregate queries that are done in Heroku. So the first one is top 3 teams with most championships. If I confirm this selection, well, I'm going to see that we have the motocross team 43 with 5 championships, powerlifting team 98 with 4, and the rowing team 54 with 7. Then I have here the team count per sport. If I confirm this selection, well, you can see that archery has 7 and strongman have 7. So what I want to do is to prove that this isn't hard coded. I'm going to go to Postman. Here I can send requests via API to my database, and I'm going to create another team. So I'm going to put test team archery, and 16 is the archery sport ID. So I'm going to send this request, and as you can see, it was created successfully. So if I go now to my front end here and I log out and I enter I think it was Dave, and password was 000000000. I sign in and I execute this team count per sport. As you can see, archery now has 8 teams and strongman has 7. So that proves that the backend works. And yeah, I have team with home championship wins. So yeah, Winston has 7, 3, 4, 5, 3. So now I want to showcase the bot. To showcase the bot, first thing I want to do is make sure I have LLaMA running. I'm going to go here to terminal. Go to here. I'm going to type LLaMA run running 3.3 to billion. So it's running, okay. And I also want to run. I'm going to close this and I'm going to open the terminal again. Sorry, I don't know the command to like get out of the LLM. So, and I want to run LLaMA run LLaMA 3.2. So now I have 2 models running. I'm not going to terminate this one. And okay. I'm just going to type something like give me a beginner friendly exercise that targets biceps. So this is running locally, so it's going to take a while. So I'm just going to speed up the video. Just answer the first question. And it said that the concentration curls exercise is a beginner-friendly exercise that targets the biceps. And just, yeah, give me everything about the exercise. So if I go here to VS Code, I can see which documents so here, if we go here, um, around here, so we can see that the user question was give me a beginner-friendly exercise that target biceps. And the first LLM, the one that is supposed to make better the question, output what is a beginner-friendly exercise that target biceps. So yeah, it added a question mark at the end. And the second LLM got these documents: the incline inner bicep curl, this dumbbell bicep curl. So this one is beginner, this one is beginner 2. So yeah, seated bicep is expert. And yeah, I got the first one that I got was the concentration curl. So this is the one that I decided to use. And it's beginner, it targets the biceps. So yeah, primary muscle is biceps, so this one is right, responded correctly, which sometimes this doesn't work because yeah, I'm using small billion parameters model um, for it, so it can run locally, and these models are not as effective, so it sometimes just hallucinates, but this wasn't the case. So what I want to do is to prove the long-term memory. So if we go to DataGrip, um, I showed the user table earlier, and this one has a column name memory. So every time you log out, it going to load, or yeah, store the conversation you had with the bot to memory. And when you sign in, it going to load the memory um to the bot. So what I can do is go here, log out, then I'm going to go to DataGrip here, and yeah, you can, if I go to here, you can see that the memory was stored. So if I go to here and I sign in again and put Dave, sign in, and I ask the bot what equipment is necessary to perform the exercise mentioned earlier. Perform the exercise mentioned earlier. What equipment? The LLM just answered the second question, and it said to perform the concentration curl, you will need a dumbbell. So it remembered that we were talking about the concentration curl, and it answered me the question. So now we're going to go to the VS Code again, and we're going to see the document for the concentration curve. Um, so as you can see, the user question was what equipment was necessary to perform the exercise. First LLM response was what equipment is necessary to perform the concentration curls exercise. And second LLM just answered for the all you'll need is a dumbbell. And as you can see, the context, the first exercise that it got was the concentration curl one, and you can see that dumbbell is the only equipment you need to perform the exercise. So the answer of the AI bot is correct. So um, lastly, I'm just going to say here my name. My name is Iram. So I want to just that how the bot responds, because in here this bot has a context, or in a sentence in the context that says you're an assistant for exercise questioning and answering tasks. Only use the following documents to answer the question. Each document has yeah. So and I said speak explicitly. If you don't know the answer, just say you don't know. So this is a emergency stop for the hallucination of the LLM, but sometimes doesn't work. As I mentioned earlier, I'm working with small parameters models, so maybe so what I want to see is the bot telling me I don't know the answer, or um, I don't have information about this question, but it's possible that bot starts to hallucinate. Let me just responded to the question. My name is Iram, and its answer was to perform the concentration curl exercise, you will need a dumbbell. So as you can see, the bot just repeated the output. So what I want to see, where is the problem? So if we go to VS Code, we can see what was the output of both LLMs, and if we go here, we can see that the user question was my name is Iram, and the first LLM response was what equipment is necessary to perform the concentration curl exercise. So indeed, we found that the first LLM response is the issue here. So the first LLM response is from the IBM model. Remember that this is a 2 billion parameter model, which is pretty vague, pretty poor. But it's the model that my computer can run locally. So yeah, this is an instruction tuned model, and I give examples of the history and the question and what should be the output. But here I didn't put any example where the question it isn't related to any exercise. So maybe given another example or more examples is going to be a solution to this problem, or or a solution would be to run a better model. I tried this with ChatGPT, and ChatGPT does this without any issue, but ChatGPT is a 100,000 billion model parameter. So yeah, this shows that AI has its limits and isn't a god. So So yeah, this was my project. Thank you for your attention, and it was a pleasure to me.